Okay, it's September the 5th. We're finishing up with 2.5. We got a couple of problems to do, and then we'll hop in 2.6 and 2.7. So they're wanting us to basically solve the quadratic equation by complete the square. And what I was referring to earlier last week when we were going over this, you cannot complete the square until you get a coefficient in front of the quadratic term to be a 1. So in doing that, this is basically what you're doing. We're going to move the constant to the other side. So I'm left with 2x squared minus 2x equals 5, right? So if I do that, that's basically moving the constant to the other side, right? Well, if I turn around and factor out a 2 from the quadratic term, that leaves me with x squared minus x, right? So if I factor it out, some things are going to take place, and I'll show you why that's there, and I'll underline it in a second. But I'm ready now to be able to complete the square on my quadratic that's left, right? So what's half of -1? Huh? Right? Yeah? Right? Half of b, right? So that'd be -1/2, right? If I square it, it becomes what? Not one, plus 1/4, right? And then notice that this 2 is going to multiply this 1/4. So when I add it to the left side, I also need to make sure that I am taking care of it on the right side. So basically, here's a 2 times that 1/4 if I were to distribute it back through, right? So I got to make sure that whatever I pulled out of the quadratic term, I have to make sure that it's multiplying by that 1/4 over there. Fair enough? What you got? I pulled out a 2 so that I could get the quadratic term to have a coefficient 1, right? Because that's really the only way I can do it. Yeah? So now, I'll just go ahead and tell you. That'll go. Half of b. B was what? -1/2. I'm -1, right? Take half of it, it's -1/2. Square it. Square -1/2, you get positive 1/4, right? So if I added 1/4 to this side, I must add 1/4 to the other side. That's exactly right. And there's that 2 times that, so I'll put my 2 times that. So I'm just keeping the equation balanced, right? So, all right, so we'll continue on. We have 2. This is x minus 1/2 squared equals, what's 5 plus, what's 2 1/4? 2 times 1/2, right? So it's 5.5, right? So that would be 5.5. Y'all agree? Okay. Now, divide it by what? 2. So that leaves me with x minus 1/2 squared equals, what's 5.5 divided by 2? 5.5 divided by 2, 2.75, right? And then I'm just solving a squared equation from this point, right? How do you get rid of a square? You take square root of it, right? What you do one side, you do to the other, but don't forget the plus and minus on the right side. So that's x minus 1/2 equals plus or minus the square root of 2.75, right? Yeah? Now, it's going to get crazy because you're dealing with a lot of decimals. What?
So where'd you get x minus 1/2 squared? Start them out.
The perfect square trinomial is, see, I took half of this. This is going to be your number there because it's really, what's the square root of 1/4? 1/2. That's right. And the square root of x squared is x. What's the sign of the middle term? So that's really what you're doing. And that's why I take the half of it, take the middle term, divide it by 2, right? I put it in parentheses with its sign because that's really what's going here, right? Because if you square it and then got to take square root, it's inverse operations. So you're basically undoing what you did. So that's why that's there. So it's the numbers aren't pretty. I'll just go ahead and tell you that. But it's at least doable. So let's kind of look at it some more before y'all. I'm going to add 1/2. So x is going to be equal 1/2 plus or minus the square root of 2.75, right? Yeah, I got to make that be a 7 and not a 2. Okay. So in your calculator, you can go 1/2 0.5 plus the square root of 2.75, which is 2.1583, and 0.5 minus the square root of 2.75, and that is negative 1.1583. So that's what x is equal. And that's where it's basically x-intercepts, right? So that's basically what you're doing. Now, let's say you don't want to do this by complete square. What other options do you have, folks? Huh? No. Quadratic formula. I mean, the quadratic formula is nothing more than a formula-based complete square. It is. Okay? So you got to be mindful of that. So don't let it scare you. Fair enough? Minus b plus minus square root, or b squared minus 40c here. All over 2a, right? Quadratic formula. It's a formula-based complete square, right? Because if you complete the square on ax squared plus bx plus c, you derive the quadratic formula. And back when we were using ThinkWell, we actually did. That was part of the problems that we had to do. All right. So just kind of know that that's a go-to. I'm not sure that I wouldn't do it on that. I'm not sure I wouldn't use the quadratic formula on that. I mean, it's just easier. People get a little bit comfortable using that. All right. For the following exercise, determine the discriminant and state how many solutions there are in nature solutions. Well, okay. If D, is greater than 0, D equals 0, and D is less than 0, right? D is the discriminant. Are you okay with that? So that means 2 real roots, 1 real root, and then of course if it's less than 0, then you have 2 imaginary roots. Now, what is the discriminant? The discriminant is nothing more than this: b squared minus 4ac. Okay? Now, that is the discriminant. But I want you to think about something. I normally, when I do the discriminants, I normally consider, I always think about it being with a square root, right? Over that. Because that's part of the quadratic formula, right? So, so when I think about with a square root over this, then it makes sense when it's less than 0 that it's 2 imaginary, right? Because if you take the square root of a negative number, it's imaginary, right? Yeah. And if you take the square root of 0, then it's just what? 0. So And if it's something greater than that, then you got a plus and a minus. It's going to be two real roots. So I was teaching this I don't know, one summer over there in one of those rooms with a big door. I mean, the windows like this with a crazy guy that's poster kind of hanging like that. Y'all know what I'm talking about? Normally they have the A&P classes in it, you know what I'm saying? So I was teaching over there one summer, way back, and I done this. He said, that's the discriminant. You just thought I'd committed murder. I thought the person was going to come unglued. They just, oh, that ain't it. I said, well, okay. But that's how I think about it because that helps me to see that I've got two imaginary, one and two real roots, right? That's kind of how my brain works. But it's the blue, it's not the green, okay? So just be mindful of that. All right, so first things first, let's ax squared plus bx plus c. Well, a is 3, and then b is -8, and c is -3, right? So -8 squared minus 4 times, uh-oh, grab the wrong one, 3 times -3. Well, you know when you square something, you get a positive number out, right? So it's 64. Now, that's -12 times -3 would be plus what? 36, right? Y'all agree? So when you do that, 64 and 36, that's 100, right? So 100 is greater than 0, is it not? So therefore, describe my two roots, right? It says how many solutions there are and the nature of them. Well, they're going to be 2, and they're going to be real, right? Real numbers. Any questions on that? That's strictly b squared minus 4ac, straight from the quadratic formula. That's correct. Yeah. Because plus or minus 100 is not, I mean, it wouldn't be plus or minus 100, it'd be plus or minus 10 on that part of it because you'd have to take square root and you still got to divide by 2a and minus b and all that. But just looking at it from a discriminant standpoint, then yeah, it's two real roots. So. All right, y'all good? No, still copying? Yeah. Mm-mm. Not during this time. You can't have class.
No, no, not about like actual homework, but can you bring the number back down how you had it before?
What do you mean?
You had it at 3. You got it at unlimited.
Mm-hmm.
So I never get to know like an answer or see if I did simple math I might have made a mistake on. Can you bring it down to like 10 or 15 or something?
I can do whatever y'all want me to do.
No, no.
All right. These are my favorite because they're basically math 1101 type problems. An object is thrown downward with an initial velocity of 3 feet per second. The relationship between the distance s it travels and the time t is given by s equals 3t plus 16t squared. How long does it take the object to fall 70 feet? So, ladies and gentlemen, how do we work this? You are? Yeah. You basically, if you wanted to see how far it took to hit the ground, then you would set it equal to 0, right? Right? And that's solving it. So when your output, and that's your is 70, so it's going to be set equal to 70. So you got 70 equals 3t plus 16t squared. And of course, in order to solve a quadratic, what do you have to do, folks? You got to set it equal to 0. Always got to set it equal to 0. So you could do a couple of things. Doesn't really matter. I could have took everything over to the left-hand side, or I could take everything to the right side. Doesn't matter which way, as long as you pick a side and go. So I'm going to clean some stuff up and go 16t squared plus 3t minus 70, right? Equals 0. All right, you want to do a quadratic formula? Since we haven't done one of those? Is that okay? So A equals 16, B equals 3, C equals negative 70, right? I always pull those out because it's just good math. And it lets you know what things ought to be, right? And I always write the equation. Because if you write the equation, you're less likely to have to memorize it because it's just kind of there. So, all right. So every time you put something in, always make sure you put it in parentheses because that negative b, if that b was negative to begin with, then you would be looking at a positive because a negative times a negative is a positive. Okay, so that's a common mistake that most people make. Let me switch colors. All over 2 times 16, right? That's 9. Let's see. What's that give me? Negative 4 times 16 times negative 70 is plus 4, 480, right? All over 32, right? Okay with that? And then that's 4, 489 over 32. That's everything over 32, right? So let's see. Is it? All right. That's some good. I like that when it happens, right? So negative 3 plus or minus. What does it tell you if that was, since it was a perfect square, what does it tell you about the quadratic? Anybody know? Anybody know what it tells you if the, nah, uh-uh. If the number underneath the radical is a perfect square, then it tells you that that quadratic was factorable. Okay, that's guaranteed. So here I go. Um, I go x equals negative 3 plus 67 divided by 2, right? And x equals negative 3 minus 67 divided by 2. So what's that? 64 divided by 2, which is what? 32, right? Oh, by 32. Thank you. I just copied 2. It's a copying error. My brain went. Okay, so 64 divided by 32 is what? 2. And then, well, that's negative 70 divided by 32, which is negative 2.1875, right? Yeah. Do what now? Oh, sweet. She nailed it. You get 2 answers, right? Because it's a polynomial with a power of 2, right? Degree of 2, so therefore you got 2 answers. But this is a contextual problem. We can't have negative time, can we? So therefore we discard the negative answer and the positive answer is the answer. So it takes 2 seconds for it to get to what? 70. Questions? You can never have negative time. If you do, then please let me know. I got some winning lottery ticket numbers I want to go back and get. Okay. So yes. Yeah. How far? Okay, right there. So just be mindful of that because word problems are the ones that are going to get you. Okay, they'll get you like that because you get 2 answers like, oh, which one do I use? Well, it's time. Time can never be negative, right? That means that's Well, okay. All right, y'all good? Yeah. Oh, there you go. So I'm going to do what? This, right? Answers 2 seconds. Dude. Yeah. Yeah, good. All right. Nobody's going to get mad because they think I killed somebody's uncle or something like that when I stepped on the bug. No? Okay, good. Okay. Well, he attacked me first, so it's fair game. Huh? What's that? No. Is that the same one that was on the wall up there? Oh, man. Gotta hate that. Huh? Not really. Nah. All right, y'all ready? Here we go. We're going to look at the length of a rectangle is 3 inches more than 4 times the width. Excuse me. So the length is 3 inches more than 4 times the width. So what's the width? We don't have a clue, right? But we know that the width is 3 more than 4 times it, right? And the area happens to be, guess what? 45 square inches. So they want to know, find the width and everything. So that's basically length times width equals area, right? So x times 4x plus 3 equals 45. All you're doing is solving a quadratic again. Width, length. Yeah. So that's 4x squared plus 3x equals 45. And then I'm just going to move 45 to the other side. So how would I do this one? Well, I'm not going to factor it. It's too big. I'm probably not going to complete the square because if I pull out a 4, I'm left with 3/4, right? That's not good. So, and I don't want to have 3/4 and square it because the numbers are really, really ugly. So I'm just going to do a quadratic formula. So A equals 4, B equals 3, C equals negative 45. So negative B plus or minus B squared minus 4AC all over 2A. So that's minus 3 plus or minus. That's the 3 squared minus 4 times 4 times, man, I'm in the same colors. I have to do this. There. All over 2 times 4. Right? So, that's negative 3 plus minus. That's 9. So, negative 4 times negative 45. Ladies and gentlemen, 720 all over 8, which gives me negative 3 plus minus, that's 729 all over 8. And I'm not sure if 729 is a perfect square, is it? I don't know. Huh? No, 25 is 6 something. So, oh, it's 27. It's 27. So it is. So here we go. So we're going to go right over here this way, and we're going to go negative 3 plus minus 27 all over 8, which is negative 3 plus 27 over 8, and negative 3 minus 27 all over 8. And those are my answers, ladies and gentlemen. So what I get, 24 and divided by 8 is what? 3, and then that's negative 30 divided by 8. Well, that's negative 30 over 8. Well, folks, first off, I can't have negative distance, can I? Distance can never be negative, so I know that my negative 30 over 8 is not going to happen, is it? Okay. So my values are, let's see, I got x, so that's my width. 4 times 3 is 12. 12 plus 3 is what? 15. There you go. And if you do that, ladies and gentlemen, that is what? 45. Yes, ma'am. Mm-hmm. Well, I was looking for, yeah, whatever my x was, whatever I defined my x at. I think it was the width. You're right. And then length was 4 times the width plus 3, right? Yeah. Okay. I got positive 3 for the width, and length was 4 times 3 plus 3, which is 15. Yeah. All right, guys. Y'all good? Going once, going twice. Speak now, forever hold your peace. Good. Okay, guys, we're in 2.6. We're looking at other types of equations. The ones that we're really going to look at this time are ones that have what are radical or rational type exponents, radical equations, period. So we're going to look at stuff that have extraneous solutions, which means it may be a solution that you solve for, but it doesn't turn around and satisfy the equation, right? It doesn't work in it. So that's why they call it extraneous. It's an extra solution that just doesn't work. Squaring property of equalities. Basically, if you square one side, you got to square the other, and however extraneous solutions may have been introduced when you do that, right? So just be aware of that. We're going to look at absolute value equations, and what else? Yeah. So uh, here we go. All right. Snap, crackle, pop. For the following exercise, solve the rational exponent equation. Use factoring when necessary. Ladies and gentlemen, first things first. I'm going to raise this to the third power. Anybody know why I'm going to raise both sides to the third power? Now, I mean, I could rewrite it. It's the third root of x minus 2 squared, right? Yeah? Because it's got a fractional power. So the denominator is the root, and the top is what the power of the radicand's being raised to. So, but we're just going to get a little crazy with some stuff. So here we go. So x minus 2 to the 2/3 equals 16. All right, guys. Remember the power to a power rule? It means you've got two powers. A power, something raised to a power, raised to another power, you multiply them, right? Yeah. And as long as, this is pretty cool. It doesn't matter what you do to an equation. If you do it to one side, you do it also to the other side, you've got it equal. And it may look whack, cray-cray, but it'll still work. So what I'm going to do is this. 2 times 3 is 6. Divided by 3 is what? 2, right? So it's basically like canceling those out. X minus 2 squared equals, what's 16 cubed? 16 times 16 times 16. How much? No. That's 16 times 3, brother. 4,096. Now I'm going to tell you something. 4,096 happens to be a perfect square. Y'all know that? Yes. Yeah, you're right. I could have done that. Can I work it twice? Okay, good. Well, my brain just went to cancel that, but she's right. We could raise it to the reciprocal of that, and we'll do it. It works a little bit nicer. You're right. Yeah, it's okay. Yeah, we'll go around the world to get there. All right, so I'll finish this one, then we'll do it like what you'd said. So if I got something squared, how do you get rid of something squared? You take the what? Square root. So I told you 4,096 was a perfect what? Right? So that's plus or minus, what is that? How much? 64? Huh, okay. So, so if I add 2, so x equals 2 plus or minus 64, right? So 2 plus 64 is what? 66 and negative 62. Y'all agree? Yeah? So that's where my brain goes. I normally take care of the denominator first, but you can do it right at reciprocal, and it works out a lot quicker. That's why I love math. And which approach is right? Both. It just depends on what your brain sees. Right? Your brain sees that, then you're okay. So let's show you what they're talking about. It might work out a little bit easier. It probably will. That's okay. So x minus, let's do this. X minus 2 raised to the 2/3 equals 16. So if I turn around and raise it to the 3/2, both of them, so snap, crackle, pop. Yeah, okay. It gets down to a little bit quicker. So these cancel out. 6 over 6, so that leaves me x minus 2 equals 16 raised to the 3/2, right? Which is really the square root of 16 cubed, right? Y'all with me? Square root of 16 is what? 4. 4 cubed is what? Thank you. So you get back to here. So we done one extra step, right?
Okay, say that whole process.
Oh, which one? The blue, black, or the other one?
No,
This side? Okay, so if you got a fractional power, you can raise it by its reciprocal, and it'll just cancel it out, right? But you got to do the other side raised to that same power as well. So that's how they got the 3/2 come about. It's the reciprocal of 2/3. All right, so when you do that, this cancels out totally. Leaves you x minus 2. Well, the denominator's a 2, right? That's really your root. So the square root of 16 is 4. 4 cubed happens to be 64, right? Or in your calculator, you can take 16 raised to the parentheses 3 divided by 2, close parentheses, enter, and it'll give you 64. So your calculator can do that as well. And when you get x minus 2 equals 64, you get the same exact thing as we got in the black and the red. Fair enough? Both are correct. Okay. You have to, oh, yes, you have to do plus and minus. You have to do plus and minus on this because it has a power of, or root of, guess what? 2 right there. And that's what you miss that unless you think about it. So, all right. Okay. Lord help me, Jesus. Y'all ready? We can do it in terms of a fancy quadratic, right? Because the linear term's half of the quadratic term, right? Half of half is a fourth, right? So I could do it like a fancy quadratic if I wanted to, and then substitute it back in. Um, let's see. We can factor out x to the 1/4 if you want to. No? Well, easy depends on the person and whether you understand what I'm doing or not. we'll factor out x to the fourth, 1/4, and then we'll see whether you're like, okay, or you're like, I'm lost. And then I can show you how to rewrite it in terms of a fancy quadratic, and then you could substitute back in. Fair enough? Yeah, okay. Y'all love let me nerd out. Man. Okay. So I can't factor out a number, but I can factor out x to the 1/4. Now that's going to leave me 4x to the what? Minus what? 1 equal to what? 0, right? Y'all agree? Here? What do you mean? Yeah, you said 4. 4's coefficient, right? Or the 1/4 being the power. If I distribute, if I distribute, I have to add my exponents, right? Like bases, multiplied, add their exponents. So 1/4 of 4 give you a half, right? So that's when I pulled out a 4th. That's really why it became a 4th. Okay. So you've got both of these. You could basically set them equal to 0. So that plus 1, 4x to the 1/4 equals 1. And then we'll divide both sides by 4. Yeah, it kind of gets x to the 1/4 equals 1/4. Now, that's the 4th root, right? Yeah? Man, what's the 4th root of 1/4? Or, let's just do this. No, is it? Let's see. How about this? What's this give me? X equals what? 1, 256. Okay. Y'all agree with that? Yeah. Mm-hmm. Yeah.
I just set both of them equal to each other and then raise them both to the point.
Really?
And I got 256x.
Yeah. That'd work too. Because what you do to one side, you're doing to the other as well. Yeah. The really cool thing about math is there's always more than one way to solve it. It's truly. Now, did the video show that?
No, I broke that up 6 or 7 times for it.
Let me show you what she's doing. She said this. She just raised everything to the what? 4th, which basically said, okay, 4 to the 4th is how much? What's 4 to the 4th? 256, right? And that would be x squared, right? Equals, what's this? X, right? Huh? That has to be x squared here, right? So, well, you basically get this. You take it back over, and you pull out an x, that's 256x minus 1 equals 0, right? So that still leaves you, when you set this equal to 0, it still leaves you 1 over 256, and this still is x equals what? 0. I mean, it still gets you there, right? Mm-hmm. That's okay. All right, so one of the answers is 256, right? Okay, so now let's look at this other one. This is 1/4, right? So if I raise both sides to the 4th, x equals what? 0. So 0 is one answer, and 1 over 256 is the other. You okay with that? You could do this, but guess what I left out? I mean, I still left with the same thing. We didn't violate any mathematical principles or nothing, which is pretty cool. Here you go. Here, I'll do this. I better stop it. All right, guys. Yay. Here's a square root problem. And we're going to solve a square root, and we're going to check for extraneous solutions. So I need you to understand one thing. In order to solve an equation with a radical in it, you must isolate the radical. And if you got two of them, you got to at least isolate one and divide and conquer, right? So to speak. And we're going to have some that have two. But here we go. So the first things first is we're going to take my negative 4, move it to the other what? Side, right? Guaranteed. So, and then, how do you get rid of a square root? You do what, guys? You square it. Good. What you do one side, you got to do to the other. So it leaves you 2x plus 3 equals what? 16. Now, minus 3. 2x equals 13. Divide both sides by 2. X equals 13 halves, which is nothing more than 6.5, right? Now, does that work? Is that a solution, or is it an extraneous solution? How do you know? You better plug it in and check it, right? I love to keep things as fractions. So this becomes what? Huh? Yeah. So that's square root of 16, right? Minus 4 equals 0. So that's 4 minus 4 equals 0. It works, right? That's right.
So define extraneous. Like, how is it? If you put, I'm assuming if you plug it in, it doesn't equal. Okay. Then how is it a solution? It doesn't work. Why is that a solution? Or is it like imaginary?
If both sides of an equation are squared, the solutions to the new equations are solutions to the original equation. However, extraneous solutions may have been introduced.
Okay.
That's why. Extraneous are solutions that satisfy a manipulated equation but do not satisfy the original equation, right? So that's how you know. So, and it satisfied it, so therefore it's not an extraneous solution, right? So, y'all good? Yeah. Okay. Bear with me. All right. So what would you do here? I hate y's and not change these to x's, just because I live in a world of x, right? So x plus 3 equals 3x. All right, there you go. Right? So what's the first thing you're going to do? What's the first thing you want to do? Yeah. You got to get rid of that radical, right? So that's square root, so I'm going to square. Look right there. What when I square the left-hand side, what have I really created now? Uh-uh. We came across this when we were looking at completing a square. This is what we created. You remember what we created? When you have a trinomial that the factors are the same, that can be rewritten as a binomial squared, right? That's called a perfect square trinomial, right? So what we've created is a perfect square trinomial. So that's going to be really x plus 3 and x plus 3, right? Equals 3x plus 7. And guess what you're going to get? Nice little quadratic, right? Um, so you can split it and multiply it, right? So that's x squared plus 3x plus 3x plus 9 equals 3x plus 7. I'm going to show you something. I'll show you, I hate to say shortcut, but it's more of understanding than anything. So x squared plus 6x plus 9 equals 3x plus 7. And then let's go here. I'm just going to take all of this over at one time. So that's x squared plus 3x plus 2 equals 0. Um, so how do we solve that quadratic? We could factor it. Yes, we could. We could also do what? What works 100% of the time? Quadratic formula and complete square works too, because we have a coefficient of 1, right? But you don't want to take half of 3, right? All that stuff. Nah. So, yeah, it's factorable, right? So, what are factors of 2 when added together give you 3? That's this, right? So, we have x plus 1 and x plus what? Equals 0. And then, let's see. Yeah, x plus 1 equals 0, x plus 2 equals 0. So x equals -1 and x equals -2. Fair enough? Now, I want to show you a really cool thing. And I'm going to show you how to go from the red to the purple. Pretty easy. So we're going to take out the black, the blue, and go to the purple. Okay? So when you do a perfect square trinomial, what you have to understand is most people go, okay, well, that's x squared and 3 squared, right? Y'all agree? But you come across, y'all remember, see if I can think about this. This may jog your brain. Y'all remember that? Remember when you had to expand perfect square trinomials with an addition, perfect square with negatives, and then perfect cubes, all that stuff? Y'all remember that? This is more polynomial theory, right? No? All right. Well, this is really what I'm about to show you, right? So a squared, most people go a squared and b squared, right? And you get the outsides. But here's what I want to show you. A times b times who? A times b times 2. Watch this. It makes life a lot easier. And this is why we can do it. So we got x squared, right? That's there. We got 3 squared. That's the 9. What's 3 times x? Times 2? 6x. So that's how you can expand or multiply a perfect square trinomial with the math behind it to do that, right? That's why that works. It'll work like that all the times. But the most common mistake is people just square the x and square the 3, and then that's it. No, you're living off the 2ab, right? The 2 times the x and the 3. So just be, it can speed up things if you want to. The more you know, the smarter you're going to work. It's okay. It's okay. No harm, no foul. Right? Just food for thought. Okay. Did we solve it? Yeah, we did. What did we say it was? -1, -2, right? Right. Yeah, y'all good? Yeah. Yeah. Hey, where can you see this again? Yeah. You can spend another night with us again. All right. That's cool. if you're bored and Netflix ain't coming through for you or anything like that, you can always do that. So, okay. Yeah, this right here, guaranteed to use a half page of paper. Guaranteed. And it's the one that's going to be like, you get all the way down to the end, you're like, because you made one simple mistake and it's like cray cray. And I hate Y's, so we're using X, okay? So here we go. All right. Now, you heard me earlier say, okay, how do you solve a radical type equation? Well, you isolate the radical. Well, what happens if you have two of them? Well, you're going to do the process twice. So you take one of them and isolate it. So do I have one isolated? Most certainly I do. So here I go. Now, the right side becomes a piece of cake. That's just x plus 8, right? Now, the left side of this is where you want to use that perfect square trinomial expansion because it's going to save your life. Do you understand what I'm talking about? The a squared plus 2ab plus b squared, right? Yes. So, huh? What? This is a binomial. Oh. Yeah, I got two things I'm squaring here, right? Now, if it was just this, take the one away, man, we could rock and roll all day long. But we can't do that. You know why?
It wouldn't just be x plus 1 plus 2 or plus 1 plus 2.
Yeah.
It wouldn't be, or was that enough?
That's enough.
You can't do that.
That's right. That's right. Gotta make sure I'm on. I'm on. Good. Okay. So, here's where we're going. Gotta make sure everybody's with me. Trust the math. It is your friend. Yeah. Yeah, it is. So, a plus b squared equals a squared plus 2ab plus b squared, right? That's what we're going to hang our hats on, right? Yeah? Okay, so. Oh, man. Okay, so let's square the first one. What happens when we square the square root of x minus 1? It just gives me what? X minus 1, right? Let's square the last one. Well, the b part is 1, right? So that would be just squaring 1 is what? Plus 1. Okay, now, let's take the a and the b and multiply them together. Well, that's the square root of x minus 1 times what? 1 times what? 2. Shoot. He got happy because we're about to do some math. That's what you're going to be left with. Now, it's because of this trinomial, polynomial theories stuff right there, right? Expanding them, perfect squares, trinomials, all that stuff. Or you can just do it like this, guys. There you go. You can multiply those two together, and guess what you're going to get? Now, look what happens. That one and that one does what? Good. So that's going to leave me with, well, those go away. Now, let's move the x and the 8 to the other side. You want to do that too? Yeah, let's do that. Or do we? No, we don't want to do that. Hold up. Let's don't do that. Oh, where you at? Okay, so I ain't gonna do 2 and 1. I'll just stop. The negative 1 and positive 1 cancel out, right? Y'all okay? All right, so that's what I've got so far. Y'all good? Good? Okay, so I'm going to move I need to isolate my radical, right? So I'm just going to move it to the other what? So what happened to my x's? They went what? Away. Wimble away. That's right. I know. My brain went there too. Okay, so it leaves me with 8 on the other side. Man, do y'all see how easy this math is coming apart? Okay, so that's going to leave me with x minus 1. The square root of x minus 1 equals 4, right? Y'all okay with that? All right. How you get rid of a square root? Square it. What you do to one side, you do to the what? So I got x minus 1 equals what? 16. So, ladies and gentlemen, add 1. X is what? Man. Boom. Now, does that work? Yeah, that works because you got 5 equal to 5, right? When you plug that in. 17 minus 1 is 16. Square root of 16 is 4. 4 plus 1 is 5. And 17 plus 8 is 25. Square root of 25 is 5. Sure can. Sure can. Now, I'm going to tell you something. The only way you get good at these is if you practice. You understand? And just as sure as God made little green apples, I guarantee that's probably going to be on the test. Because I put one on there. You know why? Because that's going to separate the haves from the have-nots, right? Those that can and those that can't. I mean, it's going to be a meat and tater type question. I put that on there. Now, I haven't looked at your test because I don't make it up. Because this whole course was copied from a master file. So Homesmiths made this one. But I'm just telling you. If I had to, yeah, that right there would be on there. So I'd make sure I knew how to do that, right? Don't let the polynomial theory mess you up over there. You got to make sure you're solid with stuff like that. Okay? The only way you get solid with that is if you practice it, if you do it. Even if you get it right, can you do another one? Yeah? And it still keep it right, correct? Yeah. I mean, once you get it right, yay, right? So your high scores always kept. You always get in practice. And you should be able to always get in and practice after your homework's closed, right? It just won't you change your score, right? Right? Yeah, up means back up to the top, or okay. Just pick one, it don't matter. Fill it in. Got it? All right. Y'all ready? I know you're saturated. It's okay. But remember, you signed up for an 8-week class. So, I know. I'm with you. That's why we're doing the videos, right? That's why we're doing the videos. We're here to help you, not hurt you, right? Yeah. Ah. Well, I'm here to make sure you can do it, right? And I'm going to show you the best ways to approach it. And I'm going to teach you how to think about things a little bit different, right? Okay, guys, we're getting into absolute values, right? Absolute values. Now, you got to understand one thing about absolute values, period. You have two answers, right? If I said, what gives me 5 from an absolute value standpoint? Well, it is what? 5 and what? But why is it that why does an absolute value always return a positive? It is exactly right. She's exactly right. It's the distance from that point back to 0. And distance, ladies and gentlemen, can never, ever be negative, period. You're not negative 5'11" tall. Go into Home Depot, do this. Go into Home Depot, say, hey, dude, I need a 2x4, negative 8 feet long. I guarantee you they'll call security on you. Yep. They will. And they'll look at you strange. Yeah. Just do it for grins and giggles. So, all right. So we're going to have a positive equation and a negative equation. All right. So I'm going to teach you how to write both. And in doing so, to get the negative, you're basically dividing both sides by -1, right? Which only changes your right side of your equation. So this is what I mean by that. So, all right, you ready? So I'm going to write the positive, and make that go down. I'm going to write the positive and the negative, okay? And if you do this, you'll be less likely to make a mistake. The positive is exactly what's written there without the absolute values. So we're going to write 9y plus 3 equals negative what? 9. Okay? Now my negative equation means that I'm going to multiply the right side of that equation by -1. So in doing that, I have the same thing in the absolute values, but my right side is -9. Now it becomes, guess what? A positive 9. Because the negative times the negative is a positive. Now, ladies and gentlemen, solve the equations, and you're done. You have 2 solutions. Yeah.
Why do you multiply the right side? What's the reason behind that?
-5 would return a positive 5, right? You're basically doing this. Some number, and then this, right? Some number. And because of the negative, it's easier, instead of having to multiply everything underneath the radical, or not the radical, inside the absolute value by the negative, you just multiply the right side by the negative and you're good. It's kind of like what happens when you have -x equals 1. You just change the sign of the right side, right? And just put x equals that. So that's really what you're doing. So, all right, so here we go. So that's -3. So that's 9y equals -12. Divide both sides by 9. And we get y equals 4/3, -4/3, right? So I simplify that. Yep. And then let's do the other side. So that's 9y equals what? 6. Divide both sides by 9. So y equals 2/3. Right? Okay. Now, it's an and. It's compound inequality, right? It is -4/3 and guess what? 2/3, right? It's both of those. Because both of those satisfy the absolute value equation. Questions? 9, -4/3, and 2/3. It should have something allow you to be able to. It may have you put -4/3, comma 2/3, right? Whatever, you know. Sometimes they allow you to do answers like that. Have you worked this one? So it puts a comma. You put a comma. She's already worked it. Yeah. Okay. All right. So I'm gonna pause. I'm gonna give you a head start. I'm gonna give you a 45-second running head start to work this one. Okay. Because I need you to be solid on this. Did you write your positive and negative? Yeah. Your positive come out and look like this. It's exactly like it, right? And then the negative is the absolute value with the right side being multiplied by negative, right? And in doing that, it left me with the 5 being a -5, right? So -2y equals 2. Of course, that's y equals -1, right? And then I'll do this one. And I got y equals 4, right? How do we do? Good? So how would I write my answer? I'd go negative 1, comma 4, right? All right. No good? Sweet. Sir? It shouldn't, because it should be, I don't think it's string comparator. It should be value comparators. Should be. Oh, man. Okay. What you want to do first? Do what now? I'm going to clear my fraction too. Now, do we have a... We do? All right. Yeah. Do we have a value for x that wouldn't work? 0. Yeah, we have an x in the denominator, so therefore we have what? Can't even think of the term. Huh? Yeah, basically x values that would make it undefined, right? Restrictions. Duh. Okay, restrictions. Okay, so we'll multiply both sides by what? X. You want 2x? See, that's going to take it all, right? Correct? Is that okay? Yeah? Because we get rid of that fraction. I mean, if we're getting rid of the fraction, I might just get rid of all of it. So when we do that, that's going to give me 2x squared minus 4 equals minus 2x, right? Ladies and gentlemen, what is that? That there be a quadratic, right? Mm-hmm. Yep. So we're going to get everything on one side and say it equals 0. You okay with that? Any questions about that? How do you want to solve this? You want to do factoring? Huh? Oh, you want to? All right, we can do that too, right? We just divide both sides by 2, right? Yeah, so that's x squared plus 1x, right? Minus 2 equals 0, right? Oh, snap. Okay. So what are values when multiplied give you negative 2, but add together to give you a positive 1? How about 2 and negative 1? You okay with that? And then with this, we're going to go right over here, right? And we're going to have x plus 2 and x minus 1. That's all set equal to 0. So we'll set each independent factor equal to 0. So x equals negative 2 and x equals what? 1. Now, is any of those a restricted value? Something x cannot be equal to? Anything? No? Okay. Hey, that TI-36X Pro that I told y'all you need to get, right? That's like $18. Yeah, you go polysolve quadratic. Hello, type that in. Polysolve. 2x squared plus 2x minus 4. Boom. Hit solve and you're done. It'll do it for you. It doesn't matter what it is. It's wonderful. You see it? Uh-huh. Yeah, hit enter. And it'll ask you what A, B, and C are. And you hit enter again to solve it. And then you're done. It should give you negative 2 and 1, right? Yeah. If you got an 83 or 84, you could graph that and find out where it intersects the x-axis. That'd be solutions as well. You can do that. Multiple things. Did you get it? You get it? Oh, I have to show you that. Before you go, come see me. All right. All right. Oh, snap. Y'all know that little thing we just done right over there? That's what we're going to do. It's called a fancy quadratic. It's fancy. It's really crazy. But I told you set G equal to the linear term, right? All right, there you go. So, if I say that's G, then this becomes what? G squared minus 6G plus 5 equal to what? See, now that looks much prettier than having to do all that other stuff, right? Now we'll factor it and solve it, and then we'll turn around and plug in what G is, and then finish really solving it, right? So that's really what we're doing. Yeah.
Is there a different way to do this, or is this the only way?
Well, that's the only way I know. Yeah, seriously, that's the only way I know.
The G is thrown. I don't understand what is G.
G's just a variable I pick. You had 26 to choose from.
Yeah. What's the point of it though? That's what I'm not getting.
It allows you to take it's quadratic. You agree? The middle term is half the power of the first one, right? So that by definition is a quadratic. And they call it fancy quadratics if you have like 10th and 5 and 6 and 3 and 8 and 4, right? Higher powers are normally what you see it. But you can have binomials in there.
Okay.
And the only way you can really deal with them is if to use the substitution, a fancy quadratic. So here we go. So are there factors of 5 when added together give you negative 6? Well, of course they are. Negative 1 and negative what? See, if this B down here is negative, but your A times C is positive, then you know you got two negatives, right? It's got to be like that. So basically what we have, G minus 1 and then G minus 5, right? All equal to 0? Yes? So I'm going to set it equal to 0 and at least get the number to the other side before solving. So hang with me. G minus 1 equals 0, and then I'll do G minus 5 equals 0. Let's take the first one first. So I'm going to add, G equals 1, right? Well, what did we say G was equal to, really? There you go. Now how easy that is? Now just finish solving that. Ladies and gentlemen, A equals 5/3, right? And then, of course, this one, plus 5. G equals 5. And then I go 3A minus 4 equals 5. So that's plus 4. 3A equals 9. Ladies and gentlemen, A equals what? 3. That's about the only way to do that. Okay? And it works pretty good. It really does. Any questions? This approach, this technique, you need to work a couple of them doing this for it to go, oh, okay. Now, and that's like something you put in your tool belt, right? We've seen it already one time tonight, right? Yeah. I used it on that thing over there. It's a good little technique. It's an algebraic technique. So that's really what college algebra is teaching you, algebraic techniques to solve things, right? Yeah. Oh, yeah. Yeah. Well, I kind of think of it like this. If you miss it, you have less tools in your tool belt to do the job. That's exactly right. Know what you know what you don't know, and get your unknowns known. All right. I put it on here. You know why I put it on here? Because I wanted to see if you could do it. You want to do it? Yeah? All right, I'm going to give you a running head start on this. Okay, guys, here we go. So I'm going to say G is equal to 2A minus 2. So if I do that, that gives me 2G squared plus 7G plus 5 equal to 0. So it ought to be factorable, right? What multiplies to give me 10, adds together to give me 7, right? What's 2 and 5? Now, I taught you the other day, and I said, guys, normally, hold up, friends. Oh, A times C. A times C. Every time you go to factor a quadratic, it's always A times C. What multiplies to give you A times C? But see, A is normally 1, right? And we normally don't have anything to worry about. But when it's something other than 1, we forget that. If you go back and look on our notes prior to this, we wrote down A times C. But you remember the other day when it was talking about, okay, hey, you can factor out the 2 here, right? And then do some things. Or you can divide out the, well, really, division and factor is the same thing. But you can divide it out at the end, right? Y'all remember that? So watch what I'm about to do. This is very important. So watch what I'm about to do. Note that I put the 2, the coefficient of A, the quadratic term, in both of these. Because what I'm going to do is I'm going to divide it out of both of them. See, you either divide it in the front or you can do it in the rear. It doesn't matter. Doesn't matter. So 2g plus 2 equals 0. And then 2g plus 5 equals 0. And of course, this is going to give you 2g equals negative 2. And of course, g equals negative 1. But I'm not done, am I? No, because what's g? 2a minus 2. So now I'm going to do 2a minus 2 equals negative 1. And that's going to give me a plus 2. So that's 2a equals 1. A equals 1 half, right? Did you get 1 half? Sweet. Okay. And now let's do it over here. I'm going to minus 5. 2g equals negative 5. So g equals negative 5 halves. And we know that g is what? 2a minus 2 equals negative 5 halves. Huh? Multiply, distribute the 2, and just keep it. Because I'd done the 2 over here, and it was nice and pretty. Oh, it'll be okay. Isn't it really the same?
Well, I mean, technically, yes, but most cases it's better.
But keep, change, flip, right? And you change it from division to multiplication, right? So, yeah. Okay. So, hey, I'm going to do exactly what I got right here. Yeah, because it's not that bad, guys. Really, it's not. It's worse. I got to add fractions, right? Okay. What fraction with a denominator of 2, when simplified, will give me a 2? 4 over what? 4 halves. So, guys, listen. 4 halves minus 5 halves is what? Negative 1 half, right? Yeah. Y'all see how I've done that? I just rewrote 2 as 4 over 2. Substitute in because 2 is denominator. Yeah? Man, I could so rock elementary right now. Just like, I wasn't that good in elementary at all. Those fraction things, yeah. This wasn't good. Okay. My brain just doesn't do this. Sorry. Y'all good with that? Do y'all see what I done right here? I can't take my brain. Look, maybe your brain does. But you would think my brain, as mathematical as it is, could figure that out, right? It ain't going there. So when I have a fraction divided by something, or something divided by fraction, then I'm going to write it out just like that. And do my keep, change, what? Opposite. Because I know that that is a viable solution for me. And then when I get done, I know that I know that I know what I done was right. I ain't got to worry about it. So, yeah. Okay. Well, any questions? How'd you do? We get the same? Yeah? Sweet. Anybody crash and burn? Yeah? Did you find your mistake? No? Okay. Don't give up. This is pretty cool. Okay? All right, let's do another. Let's see what else they got us. Oh, my. Man. Okay.
The radical first.
Well, it's got a radical in it. So what are we going to do first, guys? Isolate the radical, right? That's our game plan, right? If you got a radical, got to isolate it, right? So, what if I took that negative 5 square root of 3x plus 4 over to the other side? Would it change to a positive 5? Yes or no?
Say that one more time.
If I took the negative 5 times square root of 3x plus 4 and move it to the other side, would it change it from a negative to a positive?
Yeah.
Yes or no?
Yes.
No. Listen, you would know the answer to this if this was just 5x, right? If it's negative 5x, I said move to the other side, it'd be a positive what? 5x, okay. So you got to use that same thing. So if I take my radical to the other side, it's got a coefficient in front of it, right? Okay, so if it's a negative, I move to the other side. Laws of moving things are positives or what? Next, addition or subtraction, right? So don't let that get you. If I move that to the other side, then I can kind of clear up or clean up the left-hand side, right? Yeah, I can. Well, let's do it. I mean, ain't no reason for me to sit here and waste nerding out. Let's just do it. Okay, that's what I got so far. Then I got 3x plus 10 equals 5. 3x plus 4, right? What are you going to do? We could square both sides right now if we wanted to, right? Why? Um, well, if I divide the 10 by 5, that's not a problem. But do you see that 3/5 over there? Do you really want to expand that binomial with a 3/5 in the coefficient of x? Nah, I don't want to. And neither should you. So, no, if it didn't go into it all the way, say, look, divide 5, but that's good. It's great right there, but look right here. No. So let's keep 5 over there. So how are we going to do that? Say. You ready? Shoot, yeah, we're going to square both sides. Because we got to get rid of that radical, right? Yeah. See? This beats any English class ever. Period. Hands down. You know? All right. You want to expand this like that polynomial? You want to do that? It's a perfect square. You want to do it? Yeah, let's do it. What's 3x squared? 3x squared. Yeah, it's 9x what? What's 10 squared? 100. What's 3x times 10? 3x times 10. No.
Did you say 100 or 10?
10.
Oh.
Them different from 100.
Yeah, I got it.
All right, so what's 3x times 10? What's a times b? 3x times 10 is 30x, right? Times the 2 is what? 60x there. So we multiplied that, right? Can you write that twice and expand it?
Yes.
You most certainly can. Knock yourself out. You can do this right here. There you go. You can multiply them there two binomials together. And when you get done, you get this right here. Agree, disagree? Agree. Thank you. Now, when we square that radical, it's going to go away, right? Y'all agree? But what happens to that 5? Does it?
I don't think so.
Hmm.
No.
Does it? Yeah, it does. Has to, right? So, ladies and gentlemen, that leaves you with this. Right? No. It's worse. I do that. I listen, dude. I'm not gonna lie to you. I mean that I'm cringing because that's some big numbers.
You're gonna end up with
All right. All right. Here we go. We're going to distribute that. That's 75x plus 100 equals 9x squared plus 60x plus 100. Now, what's going to happen is I didn't preview this one, which means I didn't go and work out some of the problems ahead of time. And that's going to catch me one night. And when it does, it'll be okay. I'll go, sorry. And I'll just take it off of your homework, and we'll just keep on going. Fair enough? Because if I draw a blank on it, guess what? No. No. I'll just take it off. I'll make that bet. How's that? If I draw a blank on something, then there you go. But what do you think the chances of me drawing a blank are?
I've seen you do it.
I have done it. It happens. Rarely, but it does happen. I got that. What'd you get? Now, you got a quadratic term, you got a linear term. How you going to solve that? It's an easy way to do it. It's a 3-letter acronym. Got an F in it. And it ain't W. It's a G. GCF, right? Greatest common factor. You got a quadratic term and linear term. You can solve it by doing the greatest common factor. So what's the greatest common factor between 9 and 15? 3, good. And I guaranteed I'll take an X, right? So therefore, that leaves me at 3x squared minus 5 equals 0. So I have two factors, right? 3x equals 0, so x equals 0. Guaranteed. Anytime you have a quadratic term, a linear term, yeah.
Yeah, it would be.
Oh, yeah, sorry. I rewrote something bad. Thank you for the catch. So anytime you have a quadratic term, linear term, guaranteed one of your roots, your solution, is going to be a 0. Guaranteed. You can bet on it. Oh, yeah, we are. Yeah. Oh, yeah, we're about done. We're done right there. Anytime you have a quadratic term and a linear term, period. That's the only thing you got there. You could do this, solve it by GCF, which means pull out the greatest common factor, which can be a number, a variable, or a product of a number and variable, right? But it's guaranteed to at least be a variable on these because you have an x squared and an x, right? So you can at least pull out a variable. Now the question is, can I also pull out a number too? That's the what if. But always, one of your solutions will always be 0, guaranteed. Yes.
So zero. You got rid of your 3x.
Yeah. So divide both sides by 3, right? Yeah. 0 divided by 3 is 0, right? And I got x equals 5/3, right? Yeah? Okay? Y'all like it? It wasn't as bad as we thought. Hold up. Where are we going? Wait. We got that one. That one. Oh, snap. That one. Oh, we got 3 more left, right? Okay. All right. Well, that's all the time we have for tonight. We thank you for attending. We shall see you again on what day? Monday. Monday. If you have any homework questions or any other things you want to talk to, come see me. We'll be up here all night.